These are a few examples of practicing with rational exponents. We're going to use exponent rules, so we need to make sure that we're clear on what the exponent rules are. So the basic exponent rules are, if we were multiplying exponents with the same base, since exponents are counting multiplication and we're combining with multiplication, we can add the exponents. Okay, and this again, I really want to emphasize, if there's a plus in there, this can't be done. Okay, pluses and exponents just are not compatible. We also have the exponents when we divide. Since exponents are counting multiplication and division, we can just count those together. So we have our multiply and we're going to take away our divide. The other exponent rule is our power to power rule. So here we have A groups of x being multiplied, and then the B is counting how many groups of this x to the power A we have. So we're going to have A, and we're going to have m in groups of B, so A times B. The other part of exponents that we can use is that if we have multiplication, we can apply the exponents across the multiplication. Okay, so it looks like that, or division for that matter. One thing, again, I really want to emphasize with this is a big one, is that if we have plus or minus and we have an exponent, you cannot ever apply the exponent with add and subtract. It just does not work. Okay, this is big no-no. Okay? Exponents and addition and subtraction are not compatible. Addition and subtraction with multiplication is compatible, but not with exponents. So here we can apply these exponent rules. So I'm going to apply this exponent rule. There's a times in here, so I can apply the exponent to the 2. And power to power, well, this is a power, this is a root, so it's going to be power 3 root 4. Okay, I'm going to organize that with some brackets. Here I have power to power. I can multiply those exponents, or I can say the square root of a square root is going to be a 4th root. Here we can apply the power to power, or we can say we have power 3 in the numerator, root 2 in the denominator. 2 to the power 3 equals 8. Since this is all multiplication, I can now combine this multiplication of a to the power 3 over 4, a to the power 1/4. So we get 3/4 plus 1/4 gives us 1 whole. And then we have b to the power 3 root 2. So here there's no power to power, so this is all connected by multiplication. So then I'm going to do the 3's with the numbers with numbers, x's with x's, and I can count the exponents. Power 1/2, power 3/2 gives us 4 over 2, which is power 2. This is 5/3. Remember, that's a power 1. It's all connected by times. So we're going to end up with 5/3 plus 3/3, and that's going to give us 8/3. Okay, and we can just leave it like that.